Hello, ladies and gentlemen. Today we are on 7.3, day 3, example 5, where we left off yesterday. Today is the end of March, if you can believe it. We're going to find the exact values given one value and the sign of another. That's what it says. And there are option 1 and option 2. Two ways to do it. So when you do your homework, I want you to do some one way and some the other way, so you get practice doing both. So they give the value, sine theta equals negative 2/3, and then it tells us what quadrant we're in. Between pi and 3 pi over 2. So if you think about it, pi is here and 3 pi over 2 is here. So what quadrant is this one? Quadrant 3. So we're going to find all the other 5 ratios. So one way to do it is using a circle. So sine is negative 2/3. And sine is y over r. So when you draw the triangle, you always draw it like this, with a vertical line that has the right angle. And the y is negative 2, and the hypotenuse is 3. And then we have to find the x. Is x going to be positive or negative? We're going to do Pythagorean theorem. X squared plus negative 2 squared equals 3 squared. X squared plus 4 equals 9. X squared equals 5. X equals plus or minus the square root of 5. And because it's left, it's negative square root of 5. Because we're in quadrant 3. So now we have all 3 sides of the triangle, so we can find all the ratios. So cosine of theta is x over r, so negative rad 5 over 3. Cosecant of theta is negative 3 over 2, because it's the reciprocal of the negative 2/3. Secant of theta is the reciprocal of this, so it's negative 3 over rad 5. And if you multiply by rad 5 over rad 5, you get negative 3 rad 5 over 5. Tangent of theta is y over x. The y is negative 2. The x is negative rad 5. The negatives cancel. You get 2 rad 5 over 5. And cotangent of theta is x over y, so it's negative rad 5 over negative 2, which is rad 5 over 2. The negatives cancel. So that's using the triangle. That's the way I usually do it. But I want you to do some this way and some the next way. The next way is using identities. We're in quadrant 3. And we know sine squared theta plus cosine squared theta equals 1. So if we put in sine, which is what was given, plus cosine squared theta equals 1, we get 4/9 plus cosine squared theta. Let's change this to 9/9, because 1 is 9/9. Subtract 4/9, and we get 5/9. And then cosine theta equals plus or minus the square root of 5 over 9, which in quadrant 3, it's negative rad 5 over 3. So we got the same answer. Same answer for cosine. Tangent theta equals sine theta over cosine theta. So that's using the identities as well. Sine theta was negative 2 over 3. Cosine theta is negative 5, rad 5 over 3. So it's 2 over rad 5, which is 2 rad 5 over 5. Cotangent theta is 1 over tangent theta. So it's right there. the reciprocal. Cosecant theta is 1 over sine theta, so it's negative 3 over 2. And secant theta is 1 over cosine theta, negative 3 over rad 5, which is negative 3 rad 5 over 5. So you get the same answers. One uses a triangle and Pythagorean theorem, and one uses the Pythagorean identity. So you can pick a favorite way, but make sure you don't always just do it one way. The next thing is odd and even. If f was even in earlier chapters before, if f is even, f of negative theta equals f of theta. If you put in a negative x, you got the exact same thing. It didn't matter. And if f is odd, when you put in a negative x or a negative theta, you get the opposite of f of theta. You get the opposite if it's odd. If it's even, you get the exact same. Well, sine functions are odd because if you go theta this way, we get y, right? For sine on the unit circle. If you go negative theta, you get negative y. Y became negative y, so it's odd. But cosine functions are even, because if you go theta, you get x. And if you go negative theta, you still have x. X stays x. So the only two functions that are even are the two that are related, cosine and secant. So cosine of negative theta is the same thing as cosine of theta. So if there's a negative inside, you just ignore it and you get cosine theta. Same with secant theta. But with sine and cosecant, you bring this negative out front. Negative cosecant theta. And with tangent, they're odd as well. Negative tangent theta, negative cotangent theta. So I'm going to show you some examples of using this property. These properties, odd and even properties. Find the exact value of cosine of negative 60. Well, I know that it's even. And 60 degrees, in case you forgot, is up there. So you go right 1/2, up rad 3 over 2. Cosine is the 1/2 one. And it's negative, but cosine is even, so it's the cosine of 60. So it's just 1/2. Sine of negative 390 equals sine of negative 30 minus 360 degrees, which is the sine of negative 30 degrees, because you can add or subtract 360 at any time and have a coterminal angle that ends in the exact same place. And since it's odd, you're going to take the negative out, negative sine of 30 degrees. And when you do 30 degrees, it's rad 3 over 2, 1/2. And the sine is the 1/2, so it's negative 1/2. And tangent we're going to bring the negative out front, but first it's tangent of negative pi over 4 minus 36 pi over 4, because 36 plus 1 is 37, and 36 pi over 4 is minus 9 pi. And you can subtract pi's, because tangent every pi, that's the period. So you can just subtract pi every time and get the same. So that's the same thing as negative 9 pi is the same thing as negative 36 pi over 4. So you get tangent of negative pi over 4, and you bring out the negative because it's odd. And pi over 4, hopefully you remember, is rad 2 over 2, rad 2 over 2. So the tangent is the y over x, which is just 1. So it's negative 1. Worksheet number 98, I'm going to type it up right now. And then I'll give it back to you. So hopefully things are going well. And hopefully I'll see you on May 5th. Talk to you later.